In question 4a, we have to show that the equation 3 tan squared minus 3 sine squared minus 4 equals to 0 may be expressed in the form a cos power 4 plus b cos squared plus c equals to 0, where a, b, and c are constants. Now, we can start off by substituting tan squared and writing it as sine squared upon cos squared. So we can write 3 sine squared upon cos squared minus 3 sine squared minus 4 equals to 0. Now, taking the LCM, this will become, so the denominator is 1 in both the cases. So this will become 3 sine squared minus 3 sine squared cos squared minus 4 cos squared equals to 0. As we have to bring our equation in the form of cos power 4 at cos squared, so we can use the identity which is sine squared plus cos squared equals to 1. So in place of sine squared, we can write 1 minus cos squared. So writing 3 into 1 minus cos squared in place of sine squared and replacing sine squared with 1 minus cos squared. And this will remain minus 4 cos squared. Expanding the bracket, we'll get 3 minus 3 cos squared. So minus 3 into 1 into cos squared will become a minus 3 cos squared. And minus 3 into minus cos squared into cos squared will become a plus 3 cos to the power 4 minus 4 cos squared equals to 0. Simplifying this, we'll get 3 cos to the power 4. So the squared terms are minus 3, and minus 4. So that will become minus 10 cos squared and plus 3 equals to 0. So the values of a, b, and c will be, a will be equals to 3, b will be equals to minus 10, and c will be equals to positive 3. In part B, we have to solve the equation 3 tan squared minus 3 sine squared minus 4 equals to 0. So we already have got the equation in the form of cos. So the form was 3 cos to the power 4x minus 10 cos square x plus 3 equals to 0. Now to solve an equation like this, we can use an identity. So in place of cos squared, we can write y equals to cos squared. So in place of cos 4, we can write y squared. So this equation will become 3y squared minus 10y plus 3 equals to 0. Factorizing this, we'll get 3y squared minus 9y minus y plus 3 equals to 0. Taking 3y common, we'll get 3y into y minus 3. And taking 1 common from here, we'll get y minus 3 equals to 0. So this will become 3y minus 1 and y minus 3 equals to 0. So y will be equals to 1 upon 3 and y will be equals to positive 3. Now, as the substitution was y equals to cos squared, so cos will be equals to cos x will be equals to square root of y. Now, as one of the values of y is 3 and square root of 3 is more than 1, so cos inverse of 1 or a greater value is not possible. Cos inverse of 1 is possible, but anything greater than 1 is not possible. So we'll not be taking y equals to 3. So we'll take cos x equals to square root of 1 upon 3. So square root of 1 upon 3, if we substitute this in the calculator, the basic angle if we take cos inverse of square root of 1 upon 3, that will be equals to 54.735 degrees. Now, as the square root represents both positive and negative value, and our range for x is from 0 to 180, so we'll make the basic angle in the first quadrant, which is the positive quadrant for cos. And we'll also make the same angle in the second quadrant, which is a negative quadrant for cos. So one value of x will be 54.3735 and the other value will be 180 minus 54.735. So this will be 180 minus 54.735. Writing these value to three significant figures, the final answer will be 54.7 degrees and 125.3 degrees.